My name is Gabi, and I lead the front end for Wix Answers. And today I want to talk to you guys about something that I'm pretty sure we all share as a pain point, which is UI testing. To do that, I want to first cover the state of things, what we do now, what type of tests we write, front end, QA, see the problems in that, see some of the challenges that are unique to UI testing. Then, together with you guys, we have enough talented people in the crowd, we live code a solution together. And lastly, I'll present an exciting new project me and my team have been working on in the last couple of months. So, to start with, let's meet Anna. Okay? Anna is a front-end developer. Actually, now she moved to the dark side, but Anna is not here. And we have Dave. Dave is a QA engineer. How many of you guys are feds? Wow. QA? Amazing. So, Anna and Dave, they both work on the same feature, right? They both work on the same product. They write a lot of different tests. So, Anna mostly writes component tests and browser integration tests. Now, I'm not going to talk about the other various types of tests or enter debates on terminology because it will not end today. But both types are integration tests. And in the other end, Dave writes end-to-end tests on the same UI, but he also tests the real browser on a production environment or staging. They do this in different languages. Anna writes JavaScript or TypeScript, if she's smart. And Dave usually writes Java and now slowly starts to write JavaScript, which is amazing, and kudos for everyone involved. It is something that is enabling this talk. They use different technologies, right? Anna uses different test runners, Mocha or Karma, Jest for component level tests, and Puppeteer or Protractor or even Selenium for browser level tests, while Dave mostly uses Selenium and maybe Puppeteer in the future. One of the challenges that they both have that other parts of software engineering do not share is the variety of platforms. Okay, so it's less a concern of Anna and more of Dave's, but we have to make sure apps work on different browsers and different operation systems. But that's a small challenge. If I had to choose one thing that is the main differentiator between writing UI tests or tests that involve the UI, between other regular tests, service tests, unit tests, is the fact that unlike testing a function where the input and output is pretty clear, it's code, right? A service, when you test an HTTP response from a server, you know what the response looks like and how the input should look like. But when we're writing tests for an UI, there is no clear API. This is an example of a feature that we've been working on in Answers. We're remaking the category selection screen. So assuming that this is the product, this is the UX, and we've done it. We're putting implementation aside. We have to reverse engineer this thing and understand that this will return a list of strings. We have to write the API for that. For example, subcategories list .names will return a list of strings. We have to do the same for any feature exposed by the UI. For example, adding a category, choosing the locale. So this technique is something that most of us do, and it's called component drivers. We basically abstract away the implementation of the component, be it the low-level component or the entire feature, into an API we can use in our tests. So for those who are less familiar with drivers, it's like very similar to page objects, but not only used for pages, but for any level of component, they're infinitely nestable. Let's see some example codes. Okay, some tests. So let's take the very original example of a counter, which is also I like it because it's the most simple application we can talk about and still have a little bit of logic. So we have, this is a component level test. We render the counter using React, for example. Then we want to trigger a click on the button with the class name increment and expect that the value is now 1. This is how the test looks like without a driver. This is how it looks like with a driver. The driver abstracts away the implementation details, the query selectors, how the markup looks like, which is great. And for those who are less familiar with drivers, this is how the driver looks like. It just takes the HTML element and maps it into the features that the component exposes. That, for example, our counter has 3 features: getting the value, increment, and decrement. This is its API. And this is something that Anna might write. And then Dave needs to make sure that the counter also works when it's mounted on the website. For example, if you go to countercorp.org, you need to see a counter there. And the same should work. Clicking on the increment button should increase the value. The driver implementation, the driver the test with the driver looks very similar to the previous one. But now, instead of talking to the HTML element, we're talking to the page object element of Puppeteer. This is how the driver implementation looks like. Similar, right? So this is how the driver, the end-to-end test with the driver looks like. And this is the Puppeteer driver. It exposes the same functionality with a different API. So this example is a very small example of something that we do a lot. We do this 3 times. We do this twice as front-end developers. We write some kind of abstraction over the UI for the component level tests and for an end-to-end level test, assuming that it's a critical feature. And on the automation level, we also, on the QA end-to-end level, we also do something similar. So who is familiar with this duplication? Okay, so most of us know this, right? It has a lot of pain points. So the first one is pretty obvious. Help me out. The first pain point, the first problem of having multiple drivers. Okay, so developer breaks automation. So that's a more advanced point, and that's great. And the first point is that we have code duplication, right? Boris talked about the rule of 3. I'm very fond of. There's 3 drivers. We need to share them somehow. And obviously, we all know that if we change a selector or the implementation of a feature, it will break the E2E, it will break the integration test in the browser. So, what if we had one driver that can be used by all testers? That might help solve some things, right? Dave and Anna, they will need to translate the UI just once. This hard task, translating the UI into a driver, is hard, and most of us don't necessarily put enough effort. So we don't necessarily invest enough effort in writing good drivers. So joining forces can make it easier. Changing selectors and markup, what Shachar said, wouldn't break the test, because if I change a selector in my code and I fix my test, it will also automatically fix the end-to-end test. And most importantly, there will be no barriers between collaborators. Now Anna and Dave, they don't work in the same repository, or maybe they do, but it's not the same code base. If Dave has something that is missing on his driver, he goes and fixes it, but it won't fix Anna's, and vice versa. So, if one driver is the solution for our problems, let's create one. So I'll show the minimal example and also demonstrate the issue if it's still not clear to any of you guys that are less familiar with this problem. This is the counter we're going to talk about. It's the minimal counter. It doesn't even have an increment function. Okay? This is how it looks like. Let's see the tests. So first of all, component level tests. So very similar to the ones we've seen in the example. We render the element. We have 2 tests. The first to check that the initial value is 0, and the second to check that incrementing the value works. And we have a similar test in the end-to-end level. But instead of rendering the component in the test, We assume that we have a server running. It can be production or a local fake server. It doesn't matter. And we create the driver. I'll show the implementation of the driver just in a second. It's the same one in the previous slides. And we ensure that the feature is working. So let's run the end-to-end test to make sure that everything is OK before continuing. So this is the first test, that the first value is 0 and increment. Great. So the tests are passing. And this is the driver, the Puppeteer driver, gets a page and maps into the functionality of the counter. And the same goes for the React driver. Now, a reminder, our task is to use the same driver. So to simplify this problem, let's create a new file called drivers and put both drivers inside. I'll fix the references in a second. Don't worry. OK, so this is the file that contains our two drivers. They're both very similar, but they have some differences. What are the differences? The API, right? The framework that we're using. One of them is using a page, Puppeteer, and the other one is Element. This is a difference in the input, right? What about the output? Is the output the same? Promises, great. So one API, one driver returns promises, and the other one is async and the other one is sync. You see how the type definition of create React driver returns a function called value that will return a string, and here it returns a promise. It cannot infer the type of text content, but in this case, just imagine it's a promise string. So let's start with this. This is the easy part. How can we make the async part, the Puppeteer part, synchronous? How can we remove the promise from the definition? Ideas? So that was a tricky question because we don't. Protractor did that, and I pretty sure many of you tried to debug Protractor tests, right? It was a hell. Why? Because Protractor takes an async word and turns it into sync artificially. So no, we're going to keep it simple and stupid. We're going to transform this into async. And now that we have async await, it's relatively simple to adapt the tests. First thing, I have to turn my tests into async functions. And the second thing I have to do is just await for the value. Sorry. And actually I have to wait for the increment here, but wouldn't break the test. Simple, right? With a very simple action, we did 50% of the job. Now our driver's output is the same. So let's tackle the first problem, the hard problem. The first one receives an HTML element. The other one receives the Puppeteer page object. So an HTML element can do a lot of things. We write web apps with it. And the page object of Puppeteer can do a lot of things. It can navigate, it can measure, things we don't necessarily need in our driver. So now it's the time to find now it's the time for a good abstraction. We need to find the right abstraction above both things. And because naming is difficult, we're going to start with a very random name. Let's call this abstraction Bob. Okay, so we know that in order to have the same driver, we cannot use HTML element or page anymore. We have to use something new. And let's start with the React driver. Let's refactor the React driver to use Bob instead of an HTML element. I'll copy paste it and comment just for reference. So we start by just simple, right? I just removed the HTML element now. It receives a Bob. And I can do the same for Puppeteer. and the problem solved. But we have to make it work. So what is a Bob? What capabilities does it have? Let's examine the capabilities that we are using of the HTML element and see what API does this Bob needs. What is the first thing that it needs to do? Find an element. Okay, great. That's a little bit more. I'll leave it to the end. Okay? Second thing? Excuse me? Click. Okay. Click. Let's start with click. Okay, so it needs to have the click functionality, and we know it's a promise. So, and it doesn't return anything. And then we have this part covered. This, by the way, it's nothing fancy. It's just HTML events invoking. It works. So next simple thing is the text, right? We need to have some method that will return the text. So, sorry. So these are the two easy ones. But as you said, as many of you mentioned in the first question, we need the find method. So let's think about the API for this find method. So what will it receive? Selector, great. Which is a string, and its return value is element. Some Bob. Who said? Shachar, you know the. The return value is not an element. We're in the abstraction level of the abstraction word of Bob, so the return value is a new Bob. That's a very important part here. So let's use our new Bob to write the driver. So now we do bob.findValue.click. It looks okay. No, sorry, .text. And now do Bob. Oops, sorry. So now our signature is almost the same, right? The return value is the same, and we've taken care of the input, this Bob thing. But our tests are not passing anymore. And it's obvious, because now the create driver function expects a Bob, but it's getting an HTML element. So what is the most simple thing we can do right now? Generics, okay. What capability do we need? Factory. No, you're just throwing a lot of buzzwords. I need a what? We need to transform from HTML to Bob. Great. That should be fairly easy, right? Let's do it. We start with a function called export element to Bob. It will return a Bob. So first things first. Text is async. Text is, what do we do for text? Text content, great. Click, similar. But now we use the nice utility we had. Okay. The tricky part. How do we implement find? Query selector, but do we do the, how do we do the query selector? Okay, great. jQuery is a nice idea. Okay, so I have TypeScript here to protect me. Element is not assignable to Bob. What can we do? Great, we just wrap it recursively into a Bob. Awesome. And now our element to Bob should work. Let's just refactor this. And the test passes. But there's no big deal here, right? We didn't add any new value. We just added a new layer of abstraction. And right now, if it was the end of the talk, I just created more work. But let's get to the real juice. We do the same thing for the Puppeteer one, okay? So I'll back up it. Now, I change the input from page to Bob, okay? And now, I use the Bob API, but you guys seeing what I'm... Same thing, right? The driver stopped being React driver, Puppeteer driver. It became counter driver. And now it's focused on the what and not the how, the actual feature and not the implementation. Let's fix references. No, this is okay. This one was just a wallaby limbo. Now we go to the Puppeteer test. So if we just try and use create counter driver here, we get to the same problem. So we all know from the last example, it should be easy. We just need to have a function that maps from Puppeteer word to Bob. And I've copy-pasted the old driver just for us to have references, because I hope you guys don't remember Puppeteer API by heart. Okay, so page to Bob receives the Bob, and receives the page, yes, and returns the Bob. Okay, so let's start with the text part. Let's copy-paste the old one. Sorry. Okay. So Puppeteer's API is different. It receives a selector and then a function, and then it will find the element in the DOM, run the function, and return the value. But now the selector is part of the API call. Now, what can we do? We can't change the text signature, right? Because Bob's text signature does not receive any argument. But here we can change Bob here, but what we can do is change this function, right? We're the one responsible for this function, page to Bob. So we can do whatever we want. We can pass the selector here and solve this for now. Defer the decision. I learned something. So let's see what happens. We do click. Click is, we write the click function. It's really similar. Now we have to implement find. There's a little hint there. How do we implement find? Just for those who are less familiar with Puppeteer, you can't, the thing that you get back from the page eval function is the return value of the function. You can't change that. You can change something else, and actually the real implementation uses that, but for the simplicity's sake, using only the API that you see now, and the fact that we pass the selector, how can we implement find? Change selectors, amazing. So we can call page to Bob, but now pass the same page, and now change the selector. Okay, and now we refactor the code. Now it's expecting a second argument, the selector. And this initial selector is a great fit for the selector of the initial component, something that we didn't have to care about in the component level. But my counter is wrapped with a counter class name, which can be a great fit for the initial selector and help us namespace the whole thing. So we've done that. Let's see if it works. I really hope it does. I had it before because it was a Puppeteer test. And it works, right? But wait, I added some value. I hope that some of you have enough imagination to see how powerful this is, but let me show you a glimpse. Our counter is not complete without a decrement feature, right? So we get a request from our users to implement a decrement feature. Sorry. And I go and write the test. Great. So the test is failing because I don't have this method in the driver. So I'll do that. And now the test is failing because it's trying to dispatch an event of something that does not exist. So I'll just uncomment the code because the code of the application is less important now. And now the test is still not passing because I've done a typo. Okay, I've written decrement with an I. Let's assume I didn't notice that. I fixed the typo in the driver instead of the application because it was late or something. And the test passes. Now, let's see how easy it is for me now to add a new test on the end-to-end level. I have the method in the driver, and it took me less than 10 seconds to add a working, let's hope for it, a working end-to-end test. I'll hide the result in case something does not. And it works. And now for a real word usage. I go home, and the next day, my new sober self sees this typo, and I fix it. And now, the test is not passing, but that's not the only test. Let's keep that, okay? The end-to-end test will not pass as well. I'm a little bit short on time. I go and fix the typo in the driver, and now I hope you guys can understand that I fixed it not only for myself, I fixed it for the end-to-end as well. And that's the huge power here. So, because Bob is not a good name for a library, it's not easy to see what we're expecting to relate to the first talk. Today I want to introduce a cool project we've been working on called UniDriver. So UniDriver is the same thing we've just live coded, but with a little bit more investment and tests and features. So what is it? It can be reused in the same test levels, all test levels, can be reused by feature developer and test writer. We've seen a simple example of a counter, but this pattern is infinitely nestable. You can use drivers of components of inside drivers. That's something we all do at Wix Answers. And it's open source, okay? A little bit more about the UniDriver. So it's really opinionated about the things that it exposes. It does not expose things like trigger focus because an end user does not know what focus is. It knows how to click and how to type, mimicking a real-world user. In it, all actions are lazy and async, again, end users. And it has adapters to JS DOM. The functions that we've seen, the page to Bob, element to Bob, they're all things that come in the UniDriver. The adapters from a specific environment to a UniDriver. So if you're interested, check it out. It's on incubator right now, and hopefully we'll move and mature from it. Thank you. Questions? So the question or the statement was, my tests are still duplicated. So yes, you're right, and that's easily fixable. The only thing that is different between the tests is the setup and teardown. But my point is that duplication of tests is 1% of the problem. Most of the problem relies on the duplication of drivers. And but with this technique, you can easily share tests as well. But I'm not sure the value is there. No, the value is still on the drivers. Any other question? Yes. Okay, so I'll try to answer that. So the question was that we have an end-to-end test that covers a lot of components and it goes deep into the component level. And on component level, a test, we usually test only one. So it really depends on how you do that. I really believe that you should test the main features of each level, starting from the component and to its container and so on. So the point is, eventually it doesn't really matter. You have a component, you have its API, whether it's made by a lot of different other components, or it's a low-level component on itself. For the test, it's the same. I'll catch you up later and show some examples if you want. We also have a lot of examples using this at Wix sensors code.